Hello and welcome to this video on the IUPAC nomenclature of alcohols, and this is the second part. In the first part, we learned how to name simple alcohols. We learned how to name alcohols having saturated carbons and unsaturated carbons. But in all those examples, we looked at a situation where there's only one OH group. And now we're going to talk about a situation when there are more than one OH groups. So we're going to talk about when there are two OH groups, when there are three OH groups, and so on, and try to find out their names. So first let's start with a situation where there are two of them. So suppose you have a carbon chain and you got two OH groups. Then you have to take that parent chain which contains the alpha carbons of both and is the longest carbon chain, or perhaps rather if you have multiple bonds, then you have that chain which contains the alpha carbons of both OH groups and contains maximum number of double and triple bonds. So there is an alpha carbon sitting here, there's an alpha carbon sitting here, and we have to use the chain that includes these two and is the longest carbon chain. So obviously it is this chain. And we have to number it from the end where the first OH gets the lowest number. So I'm going to number it from the right side. So let's check the statement of this. And the name, of course, that will happen here is, for alcohols, we said take alkane, put suffix -ol, and since it starts with a vowel and this ends with a vowel, remove this E and you call it alkanol. But now since you have two OH groups, we'll call it a diol. And since it starts with a consonant, we can retain the E of the alkane. This is going to be alkane. And then hyphen PQ hyphen diol, where P and Q represent the position numbers, the locant numbers. So, if there are two OH groups, then the parent chain is the one which is the largest carbon chain that includes both the alpha carbons. The molecule is named as an alkane diol with position numbers preceding the suffix diol. Now remember, I'm talking about the largest carbon chain because I'm going to take an example of a saturated carbon. If it is unsaturated carbon, then the two alpha carbons should be included along with including the maximum number of double or triple bonds. So let's take an example and we'll be able to find out. Now again, as usual, pause the video, number it, name it, and then play the video back to check your answer. Now first identify the alpha carbons. This is one alpha carbon and this is one alpha carbon. Now that we have identified them, the chain that includes these two must be happening in the parent chain. So it has to be this. But then we have to look for the longest carbon chain apart from these. So this means it extends here and this extends up to here. So the two alpha carbons must be included in the largest carbon chain if it is saturated. So now let's look at the numbering. If I do the numbering from the left side, I get 1, 2, 3. The first OH occurs on 3. If I do it from the top, 1, 2. The first OH occurs on 2. So we prefer the numbering from the top. So this is how we do the numbering. Now we got 6 carbon atoms here. So what is the parent? The parent is going to be called hexane. I'm going to retain the E. 2,4-diol. This is the parent name. And there is only one substituent sitting at 3, and this is isopropyl. So this is going to be 3-isopropyl hexane 2,4-diol. Let's take one more example. Pause, name it, play it back. Now, which are the alpha carbons? Alpha carbon here, alpha carbon here. So I must join these two and get the carbon chain which is having maximum number of double and triple bonds in this chain. So it has to extend this way and this has to go this way. So this is the parent chain. How do you number it? Number it so that the alpha carbon of the OH gets the lowest number. So 1, 2, 1, 2, 3. So 2 is preferred. So here remember, the alpha carbon of the OH gets precedence over double or triple bond numbering. So numbering from the top. So what is the parent? The parent is hex 5 ine 2 4 diol. And then you put the prefixes, and in this case you have the isopropenyl sitting at 3. So this is going to be 3 isopropenyl hex 5 ine 2 4 diol. So this is the situation when you have 2 OH groups. Now let us understand what happens when you have 3 OH groups. Now when you have 3 OH groups, there are 2 possibilities. One OH here, one OH here, one OH here. The first possibility is that the alpha carbons of all the 3 are such that they can be taken in one single chain. In this particular case, you will notice that the alpha carbons of the 3 OH, which I have marked by a circle, they do occur in a single chain. Now takes the maximum number of carbon atoms or maximum number of double and triple bonds. So it is the entire length of this chain which can be taken as a parent chain. Then this will be named just like a diol, like a triol. So it will be PQR triol, alkane PQR triol. So if there are 3 OH groups, then 2 possibilities exist. The first, where a chain can be found in which all the alpha carbons can be located. In such a case, the molecule is named as an alkane triol with position numbers just before the suffix triol. Check this out. Pause, name it, and play it back. Now look at the alpha carbons first. Alpha carbon is here, alpha carbon is here, alpha carbon is here, and you'll notice all of them are in one single chain. So extend this both left and right to get the maximum number of carbon atoms because all of them are saturated. So this becomes the parent. Numbering has to be done from the right side because if I do it from the left side, what happens is 1, 2, 3, 4. I get a 3, 4 OH group. 1, 2, 3, but the next OH group goes to 6th position. So 3, 4 is better than 3, 6. So numbering from the right side. So what is the parent? The parent is nonane. 3, 4, 7, triol. And now put all the prefixes. And in the case of prefixes, I guess you have methyl here, and ethyl here. And obviously ethyl will come first. It is 5-ethyl, 4,6 dimethyl, and the parent. So this is the name: 5-ethyl, 4,6 dimethyl, nonane, 3,4,7 triol. Okay, so this is the situation when all the OH groups, all the alpha carbons happen to be in one single chain. Now the next situation is when 2 of them are in one chain, the third one is not. If there is no chain that contains all the alpha carbons, then the parent chain is the longest carbon chain that contains 2 of the alpha carbons. The other OH group is named as a prefix hydroxy. In this case, the parent would be a diol. So remember, suppose I have a situation now I can have a carbon chain containing 2 OH alpha carbons here. These are the alpha carbons, and notice all of the 3 are not in one chain. So in this case there is 2. If I go like this, it is 2. If I go like this, it is only 2. So in any given chain, only 2 alpha carbons exist. So if all the carbons are saturated, then go for that one in which you have maximum number of carbon atoms. This is the example. Pause, name and play. So what do we do here? Well, I've got alpha here, alpha here, alpha here. So if I number it this way, if I look at the pentane like this, 1, 2, 3, 4, 5, 6, 7. And if I number it like this, 1, 2, 3, 4, 5, 6. It's only 6. So this one doesn't work. 1, 2, 3, 4, 5, 6. So there is only one chain that contains 7 carbon atoms, including the alpha carbons. There is one particular mistake. OH is not 1. The 1 is this. 2, 3, 4, 5, 6, and this is of course 7. So numbers have got a little bit, shifted to the right, but this is the right numbering, the ones shown by the red. So if this were the case, then what would be the name? Well, the name would be, you have 5 and this would be 1, 2. In 5 you got a substituent 1, 2. We name it as 2-hydroxy ethyl. And this is sitting at carbon 5. So 4, not carbon 5, it's 4 because everything is shifted to the right here. So this is the 4th carbon. So 4-2-hydroxy ethyl heptane 1, 5 diol. So this is how you name this particular compound. The next point is, what happens if there are 4 of them? Then there will be 3 possibilities. The first possibility is in which all the alpha carbons are in a single chain. The molecule will then be named as alkane PQRS tetraol. Look for the alpha carbons first. Alpha, 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 alpha. And can you see this chain? All of them are in that chain. Extend it. Extend it. You get maximum number of carbon atoms as well as maximum number of double and triple bonds in this case. So and where do we number it from? We can number it from the right side. 1, 2, 3, 4, 5, 6. Number from the left side. 1, 2, 3, 4, 5, 6, 7, 8. So my left side numbering is not going to work because the OH group occurs at 3 and 7, sorry 3 and 6, but from the right side I get it at 3 and 7. One, two, three. Sorry, it's 3 and 4, not 3 and 7. It's 3 and 4. So I get 3, 6 and 3, 4. 3, 4 is better. So I've got to number it from the right side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the parent is a tetraol. So it's going to be decane 3, 4, 5, 8, tetraol, and now put all the prefixes that you have. In the case of prefixes, I guess you have, in fact it's not a decane because there is a double and triple bond. So let me write it again. It is going to be dec 9n 6 ein and 3, 4, 5, 8 tetraol. So, and then you put the prefixes. There is one here, and this is isobutyl, rather secondary butyl. It's not isobutyl, secondary butyl, which is sitting at 4. So the name becomes 4 secondary butyl dec 9n 5-ine 3,4,5,8 tetraol. So this is one situation. The second situation, when there are 4 OH groups, is when 3 of them are in one and one is different. So in that case, it will be named as a triol with one OH group as a substituent. So let's take this example. Alpha, 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 and alpha. And you notice any 3 are in one line. In fact, these are in one line 3 and these are in one line 3. There are only 2 such chains. So look for the carbon atoms. 4, 5, 6, 7, 8. And if I do it this 1, 2, 3, 4, 5, 6, 7. So in one of them I get 8, in one of them I get 7. So I'm going to go for the 8. And the numbering has to be done from the right side so that the first OH gets 1. So 1, 2, 3, 4, 5, 6, 7, 8. And the substituent 1, 2, 3. So the parent is octane 1,2,7 triol, and the prefix is going to be 4,2-hydroxy propyl, and then the parent name. So 4,2-hydroxy propyl octane 1,2,7 triol. And the next possibility, the last possibility, is if any 2 are in one chain and the other 2 are not, then the parent is a diol and the other 2 OH will be substituents. Pause, name and play. Alpha carbon, alpha carbon, alpha carbon, alpha carbon. Notice that no 3 alpha carbons are in one chain. Go like this, 2. If you go like this, 2, go like this, 2, go like this, 2. So only 2 carbons are in one chain. So now which one do I select for the parent chain? Obviously I like to go for the one in which I get the longest carbon chain. Now let's see if there are more than one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this fellow is 9. Now let me change the color and let's see if we can get some. Okay, let me get this blue color. So another option could be 1, 2, 3, 4, 5, 6, 7, 8, 9. Again I get 9. So I get 2 chains with 9, and then there is 1, 2, 3, 4, 5, 6, 7, 8. 8 is not going to work. And 1, 2, 3, 4, 5, 6, 7, 8. Again there is an 8. I guess this is the best choice. So these are the 2 options that I have. So the options that I have are one is this chain, the other is this chain. Now in the horizontal chain, if I take this chain, I get substituent 1, 2, 3. 3 substituents. If I take this chain I get 1 and only 2. So maximum number of substituents. So we have to go for the maximum substituent, which is the horizontal one, and I'm going to be numbering it obviously from the right side, because from the left side the position is 2, from the right it is 1. So number it like this: 6, 8, 9. Now, so how do we name this? It's going to be a diol system, and these two are the hydroxy systems. So if you number the side chains, 1, 2, 1, 2, 3. So this is 2-hydroxyethyl, this is 3-hydroxypropyl, nonane 1,8-diol. 7 2-hydroxyethyl, 5 3-hydroxypropyl, nonane 1,8-diol. So this is how we name polyhydroxy compounds. I hope this video helped you in understanding how to name polyhydroxy compounds. If you have any questions, any doubts, any queries, please drop in at the comment section. Thanks for watching.